Welcome to Facts Up Daily, your daily destination for the world's most fascinating facts.
I am absolutely thrilled you're here today because we are about to embark on a seriously wild, carefully curated journey through space. We're going to dive into 20 mind-bending space facts derived directly from astronomical research that will, for sure, completely change your perspective on reality. Trust me, by the time we wrap this up, you won't look up at the night sky the same way ever again. Okay, let's dive into our cosmic itinerary for today. We have 4 chapters. First, our bizarre solar system. Then we'll zoom out for mind-bending cosmic scale, followed by extreme gravity and physics. And finally, we'll wrap things up with time, silence, and perspective. All right, Section 1, our bizarre solar system. Let's look at some local cosmic quirks hiding right in our own backyard. Now, what's really interesting here is the sheer variety of weird behaviors right next door to us. Take Mars, for example. It's home to the largest volcano in the entire solar system, Olympus Mons, standing a staggering 13.6 miles tall. Move over to Saturn and the physics get even weirder. Its average density is so incredibly low that if you could somehow find a gigantic ocean of water large enough, the entire planet of Saturn would literally float in it like an apple. Then you've got Uranus, making itself one of the strangest planets by completely rotating on its side. And finally, little Mercury zips around the sun so fast that a whole year there lasts only 88 Earth days. But if we're talking about planetary weirdness, Venus is a fascinating mini mystery all on its own. A single day on Venus, meaning one full rotation on its axis, actually takes longer to complete than its entire year orbiting the sun. Let that bizarre concept of time sink in for a second. A day outlasting a year. And then there's its temperature paradox. Venus is the hottest known planet in our solar system. The catch? It's not even the closest planet to the sun. Mercury is. Venus's thick atmosphere just acts like a giant cosmic greenhouse, trapping all that heat inside. Let's bring our focus back a bit closer to Earth for a quick high-energy speed round. Right above us, the International Space Station is hurtling through space at a blistering 17,500 miles per hour. Because of that incredible speed, it completes a full orbit around our planet roughly every 90 minutes. But contrast that intense, high-speed human engineering with our closest natural neighbor, the Moon. Up there, there's just this eternal, undisturbed stillness. Because there's virtually no wind or rain, the very footprints left behind by human astronauts could easily sit there for millions of years. Let's move to Section 2 and see how this builds into our mind-bending cosmic scale. Fair warning. We are about to leave human comprehension completely behind. And this brilliantly illustrates just how tiny we are. The sun contains 99.8% of all the mass in our solar system. That means literally every single planet, every moon, every comet, every asteroid, and every human being combined makes up just a tiny, almost invisible 0.2% sliver that's left over. And to really anchor what that remaining 0.2% actually looks like, let's talk about the number 1,300. That is how many Earths could fit inside the volume of Jupiter alone. Think about that. Our entire world, everything we know, multiplied 1,300 times just to fill the space of one single gas giant in our local neighborhood. But honestly, Jupiter is just a speck when we zoom out to the scale of deep space. Scientists have already discovered thousands of planets outside our solar system. Exoplanets, right? Zoom out further, and all of those are contained just within our Milky Way Galaxy, which is estimated to be an absolutely massive 100,000 light years across. But we can't stop there. Zoom out to the observable universe, and there are billions of other galaxies out there. And inside each and every one of those billions of galaxies are millions to trillions of individual stars. When we try to process numbers like millions to trillions of stars multiplied by billions of galaxies, our brains frankly just short-circuit. So the crucial point is this. There are more individual stars in the observable universe than there are grains of sand on all of Earth's beaches combined. Every beach, every desert shoreline, every single handful of sand. The stars outnumber them. Section 3. Extreme gravity and physics. Let's shift gears and look at the chaotic and terrifying forces out there. We just talked about immense size, but now let's talk about immense density. Neutron stars are the collapsed cores of massive supergiant stars, and they are packed so incredibly tight that just a single teaspoon of a neutron star's material would weigh billions of tons if you brought it here to Earth. Billions of tons! In a teaspoon. But even a neutron star's gravity pales in comparison to a black hole. The event horizon is the ultimate boundary. It's the perimeter around a black hole where the gravitational pull becomes so unbelievably strong that not even light itself can escape once it passes through. It is an absolute point of no return. Once anything crosses that boundary, it is fundamentally, permanently gone from the observable universe. And what exactly happened if you were to cross that boundary? Well, spaghettification. It sounds completely made up, but I promise you it's not. This is the actual, legitimate term scientists use to describe the fatal process where the extreme gravity of a black hole violently stretches an object or a person as they fall into it. Because the gravity is so much stronger at your feet than at your head, you would literally be pulled into a long, thin noodle of atoms. Science is fascinating, absolutely, but man, it can also be incredibly brutal. All right, let's bring our heart rates back down for section 4, time, silence, and perspective. Let's safely back away from the black holes and start with an everyday magic trick that you've experienced your whole life. Light from the sun takes about 8 minutes and 20 seconds to travel through space and reach Earth. That means whenever you walk outside, look up, and feel the warmth of the sun on your face, you are not feeling the sun as it is right now. You are interacting with energy from over 8 minutes in the past. Every single time you look out into space, you're literally looking backward in time. And while you're looking up at all those violent stars and swirling galaxies, remember this. Because sound cannot travel through a vacuum, space is completely and eternally silent. There are massive explosions, colliding galaxies, and stellar flares constantly happening all around us in the cosmos, but they all happen in absolute, infinite quiet. Which brings us to this staggering number. 13.8 billion. According to our absolute best scientific evidence, this is the age of the universe in years. Think of that profound scale. 13.8 billion years of cosmic evolution, of stars being born and dying, of galaxies forming, eventually leading up to this exact moment where you and I can sit here and try to make sense of the whole shebang. So what does this all mean? It leaves us with one final, profound question to ponder. In a 13.8 billion-year-old silent universe filled with billions of galaxies, governed by strange physics, and boasting an unimaginable scale, what else is waiting out there in the dark? We have only just begun to scratch the surface. Thank you so much for joining me for this explainer. I really hope this journey through our cosmic curiosities has empowered you with a deeper understanding of our universe and, more importantly, left you hungry to keep exploring. Keep asking questions, keep looking up, and I'll catch you in the next explainer.